This three-story tower room at the Thorlabs headquarters in Newton, New Jersey houses our fiber draw towers. These towers produce many of the optical fibers we offer in our catalog, and also gives us the ability to draw high-quality custom fibers for a variety of applications. The draw process begins by cleaning all surface contaminants from the silica preform. The internal structure of an optical fiber is already present in this 1 meter long glass cylinder. 1 quartz handle is welded onto each end of the preform using an oxygen-hydrogen torch that heats the glass to 2000 degrees Celsius. Eye protection is required to shield the engineer's eyes from the brightness of the torch. Once both handles are attached, they are mounted or chucked into a lathe, suspending the preform over the water-cooled half-moon burner. As the lathe rotates the preform, the burner slowly passes along its length, removing all surface contaminants. This process is called fire polishing. The moving burner mills off the outermost layer of glass and removes all organics that may be present on the preform. The more pristine the preform, the higher quality fiber it yields. Once the fire polishing is complete, one of the 2 handles is removed, leaving a pointed drop end. The other handle remains welded to the preform and serves as the support end. The support end is removed from the lathe and chucked into the top feed unit at the top of the draw tower. The unit lowers the preform into the furnace where it is heated to 2000 degrees Celsius. This graphite resistance furnace has an element that surrounds but does not touch the preform. The graphite allows for an even distribution of heat around the glass rod. The fiber is pushed by the top feed unit and pulled, first by hand and then by capstan, down the length of the tower. After exiting the furnace, it travels through a 150 centimeter long cooling chamber. Chilled water and helium gas keep this chamber at an internal temperature of 12 degrees Celsius. The fiber exiting the cooling chamber has been cooled to room temperature and is ready for coating. A variety of polymer coatings can be applied to our fiber depending on the application. A carbide die at the bottom of the conical coating cup ensures that the coating is applied evenly around the fiber. The coated fiber then passes through a set of UV lamps where the coating is cured. Finally, the fiber receives a blue Tefzel jacket to protect it from mechanical damage and is then spooled. The fiber is closely monitored as it makes the 36-foot journey from the top of the tower to the capstan below. 3 meters provide real-time diameter measurements to computers controlling both the speed of the top feed and the capstan. These speeds are constantly being adjusted to ensure a consistent diameter throughout the length of the fiber. Our engineers also monitor the location of the fiber as it travels through the many devices and make adjustments when necessary. It is important that the fiber is perfectly centered because any rubbing will negatively affect the quality of the end product. This tower can produce fiber as thin as 50 microns in diameter, which is about the thickness of human hair. The finished fiber undergoes a 4-axis proof test to measure its strength. This thin optical fiber is stronger than stainless steel of the same thickness when pulled along its length. Engineers also measure the attenuation and centration of the fiber. Any fiber that does not meet spec is not sold. The fiber drawn here is sold bare and is also made into connectorized patch cables or incorporated into many products in our ever-growing line of photonics equipment. This fiber will be sold to laboratories all over the world and be used for everything from optogenetics to telecommunication applications.